Hey, Ivan, how's it going? How are you
Good.
doing?
How are you?
Doing pretty good, doing pretty good. So it is great to have you on this podcast. And today we are going to be discussing something really interesting, which is like you built out an example utilizing Edge AI, like we're creating an Edge AI implementation within the Harper platform. And I'm excited for us to discuss more about that. So I want to
Cool.
share the floor and have you take it away.
No worries. Yeah, so we'll share a link to the GitHub repo. It's public within the Harper organization. And basically, what we built is an example of using uh, TensorFlow JS to run AI inferencing at the edge, which within the Harper space means within a Harper instance that you've deployed to the edge. Now, the logical question everyone asks is like, number one, why would you do this, right?
Yeah.
And the answer is because typical AI systems with inferencing are deployed the same way every other service oriented architecture is. You have an inference service with an API gateway and load balancing and auto scale and blah 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 and all the stuff.
Hmm.
Great, but Harper provides a bunch of that stuff for you for free, which means if you can run your model in a Harper instance at the edge, you are so close to your customers who are doing things, actually invoking that service. You'll be able to see round trip times of 5 milliseconds, and then you just have to add the inferencing time to that. So we're measuring inference times. We're round tripping inferences between uh, 10 and 50 milliseconds for an inference, which means effectively real time inferencing for customers. So what does that mean in real terms? Like, say you're an e-commerce company
Yeah.
and you're
Yeah.
like, you got customers coming to your website and they're typing stuff on their computer and they are trying to find a cat box. I don't know. A cat box. Cat box is something I had to buy lately. So, you know, well, they're typing away and they're like, find me the best cat box that my dogs can't get into, right? And typically you would search, they do your search, they'd find your product pages and they dig down and they go through. And what every retailer in the universe has learned is that, well, just because they search, they might not have found what they want. So you want to do product recommendations, right? Well, product recommendations are something that you can do an inference at the edge.
Mm.
You've got your customer data, you've got their search terms, you've got their history, you've got a bunch of stuff about it. And if Harper is embedded in your e-commerce stack the way we are for so many, providing so much benefit,
Mhm.
then that inference takes 50 milliseconds, and you've got a set of product recommendations that are customized to that customer.
Mhm.
So you're not calling all the way back into some cloud, doing a whole bunch of
Mhm.
stuff and getting the answer, and then your inference comes back, and they're like, small, short attention span theater. They're like, I don't need a cat box. I need a dog house. And
Mhm.
you've got recommendations for cat boxes. Doesn't matter, right? So the faster you can deliver them, the better. Now, the other reason that this is interesting is because not only you don't just want your recommendation model sitting at the edge,
Mhm.
you actually want all of your models that are customer used sitting at the edge. And Harper
Yep.
gives you the ability to put all of them out there
Mhm.
and to integrate them into your stack.
Yep.
And the critical piece of deploying our AI framework, of which the inferencing at the edge is just one component,
Mhm.
is that Harper has other capabilities that allow you to do observability and model management and training. So if you're using our pub sub infrastructure for
Mhm.
your inferencing at the edge, you can publish telemetry and inference information back to your main cluster running within Harper.
Yep.
So you recommend 3 cat boxes and the customer clicks none of them.
Mhm.
Regardless of what your inferencing confidence level is, they were bad recommendations. So now you've got your features that went in, your
Mhm.
recommendations that came out, and your
Yep.
customer data that is what they actually did, what they searched for, and what they ended up selecting and putting in their cart. That data can go back to your main infrastructure where Harper's running model management.
Yeah.
And after 25 failed recommendations, I'm picking 25 out of the air, but after recommendations, your system could be like, well, this isn't working. I need to retrain
Hmm.
my model.
Mm.
Can
Yep.
automatically retrain your model,
Hmm.
and then it can automatically deploy it back out to the inferencing at the edge infrastructure.
Hmm.
And it can divide your traffic among the two models to say, I've
Oh,
got the old
nice.
one and I've got the new one. And it can
Hmm.
inference through both of them. And if the results of the new one are better than the results of the old one, it
Yep.
can just seamlessly and transparently deploy and decommission the old model. And it
Oh,
can
nice.
just continuously
Mhm.
improve based on scores and outcomes that you set for the system.
That
So
is phenomenal.
it's not all wired into this example, right? This
Hmm.
is
Yeah.
literally
Yeah.
just inferencing at the edge example.
Yeah.
Uh, but the inferencing at the edge is the beginning of that entire framework that we're
Hmm.
building
Yep.
and are bringing to market in what we're doing within Harper. So I'm going to stop there because I
No, yeah.
probably glossed over a whole bunch of things and you have questions. And
No,
I
no, I mean, that's phenomenal. And sort of even just thinking about one thing I really want to highlight and just really ask more of is like performance, right? You talked about between 30 to 50 milliseconds on average, like around round trip, right? What does the model load time, like, what does that look like? The memory usage and even like throughput, which I think you sort of touched upon as well. But like,
yeah,
yeah, what does model load time look like?
but speeds are easy because it's not an issue. Like we can scale horizontally to have as much of this as we want. Um,
Yeah,
from a latency and what was the other parameter you gave
it
me?
was model load time.
Model load time. So these
Mhm,
things all happen when Harper stands up. You don't even
mhm.
notice it. Like
Yeah.
because we are running a edge platform that's a bunch of what we call distributed microliths. So you've got
Mhm,
the whole process running at the edge, distributed
mhm.
across the world, doing stuff.
Yep.
These models load at load time. The constraint is model size, right? You
I see. Yep.
wouldn't want to run giant models this way. You'd
Mhm.
never run an LLM at the
Yeah.
edge. Like that's like running a data center at the edge, right?
Yeah.
Makes sense,
Yeah.
right?
Yeah. Oh, yeah.
There are a ton of edge optimized models, and you don't even have to fully optimize your model for the edge to take advantage of this because we do have a full process size. Like we're running
Okay.
on compute nodes at the edge. And
Yep.
with some of the more recent announcements from our partners who are investing
Mhm,
in deploying GPUs at the edge,
mhm.
you're going to be able to get even more capacity for larger models at the edge. So you don't
Yeah.
have to do tiny ones. But think of these models as being between 50 and a couple hundred megabytes, like of model, right? Like
Yeah.
they're quantized, like they're
Mhm,
simplified down to being quantized. They're optimized by removing all the internal nodes you don't need. Like they
mhm,
are
mhm.
compressed, optimal, efficient models,
Yep.
but they're not like models that you need to they're not models sized for a Raspberry Pi.
Yeah. Yeah. Oh, absolutely. Yeah. Yeah.
Full up solid models just running at the edge
Mhm.
because
Yeah.
we have
And it,
pretty good compute infrastructure.
yeah. And initially, I mean, it's really just load time, essentially initial load time for the most part. And that's primarily it is what I'm getting from this as well. Correct me if
Absolutely.
I'm wrong. I
Absolutely.
see. Okay.
Load time and model size are kind of the big things, but because we're running a platform that happens at initialization and you don't really have to notice it. Uh, and here's the other thing that's kind of funny about this, which
Mhm.
is one of the reasons why I'm so excited. If this whole infrastructure for AI inferencing just went belly up,
Yep.
like if the whole thing just someone unplugged the socket, which would be
Mhm.
funny. There's no unplugging the socket. But if
Yeah.
catastrophic failure, the whole ML AI infrastructure just fell off the planet.
Yep.
You're still selling stuff the way you are today, just with no recommendations. It doesn't change, like there is no risk to it. There's only upside. It just makes it just improves outcomes. It doesn't actually have the impact to reduce outcomes
Mhm.
unless you train models to give negative recommendations, right? Like
I see. Yeah.
you want cat boxes, but let me show you pink mittens is not
Yep.
going to get your not going to improve sales
Mhm.
necessarily. It might
Who knows?
be an outlier.
I mean, bundle it. I don't know. I mean, no, but yeah.
And and we're using all open models, Hugging Face,
Hmm.
models from wherever that are effectively open. And we've had models running, and we've been able to run models for doing things like product recommendations, price sensitivity testing. So how sensitive are customers to different price levels? Um, and then we've also got obviously implied as the A/B testing and blue green type
Yeah.
testing of what's going on.
Yeah.
But there's a ton of other models that are obviously usable in e-commerce to test things out, like seasonality, um, and kind of a hidden value that isn't really hidden when you're in e-commerce, especially if you're in like the EU. You
Yeah.
got to deal with like GDPR
Yep.
regulations or
GDPR, right? Yep. Hmm.
data privacy, or you're just generally a nice ethical human being and you care about that stuff.
Yep.
Like I am. I don't live in the EU. I'm not
Yep.
bound by all the data privacy legislation that's over there.
Hmm.
And at the same time, it's sort of my philosophy and ethos that consumers should own their data, not companies.
Yeah.
So one of the things about this infrastructure that's really nice is because it's running within a customer that's running an e-commerce site and they own the customer profile, they own the infrastructure, they own the website, they own
Yep.
all of the stuff, and that
Hmm.
they can ensure that when they're making the inference, when they're making the call to this AI infrastructure,
Yep.
no customer PII is embedded in that. So it's just a
See.
feature vector in,
Hmm.
anonymous feature vector in,
Hmm.
and recommendations or inference output out with confidence levels. So
Hmm.
when you send that all back to your main data center for training,
Yep.
you literally have the ability to build up a really robust data set for ongoing improvements.
Yep.
It contains no PII.
As I said, without containing or without compromising personal, yep, PII. Yep. I like
So
that.
so that's like kind of the antithesis of a lot of the AI service providers that are out there today, right? Like
Yeah.
a lot of them are just trying to figure out how to monetize, how to improve. And
Yep.
and and that kind of is what gets me up in the morning. Like, how do we make AI actually work, like practical? It,
Hmm.
it's great that everyone and their brother could say, hey Siri, turn on my lights. But do I really
Hmm.
need AI to turn on my lights?
Hmm.
Hey,
Yeah. No, not really. No, just flip a light switch. I could do that instead. But
I'm old enough that
yeah.
I can just clap. And
Oh, yeah, clap on, clap off. There you go. Yes, the clapper. Yeah, the clapper. Right, the clap. Yes, yes, yes.
I mean, what did Siri really do, or Alexa, or Hey Google do that was any better than the clapper for me? Right?
Yeah,
Like, I
yeah,
don't
yeah.
really need it listening to me all day, every day.
Hmm.
I can figure that out. But
Right.
when I go shopping, I absolutely want things like the recommendations made to me to
Hmm.
make my shopping experience. I'm what we call a SWAT shopper, and by
Hmm.
SWAT, like the guys in black uniforms that show up and they're like all business, right? Like that's how I shop.
Yep.
I
Yep.
show up, I pull into the parking lot, and if
Hmm.
it takes me longer than 12 minutes to get back to my car,
Yep. You're on a mission. You are on a mission. That's me. That's me. I'm
I'm
always on a mission. So it's like this is what I came here for. No side questing, but this is it. These are my main objectives. So yep.
and I'm like that about shopping online too, right? Like I'm like
Hmm.
I want this one thing. I need to find the best thing that solves this problem. And
Yeah.
there's so much stuff online.
Hmm.
People are publishing
Hmm.
SEO optimization, this metadata fixing that, like tagging stuff X, Y, and Z. Uh, It's a place where inferencing and AI actually does tend to help me
Yep.
find the one I care about because I don't want the one that has 17 bells and whistles. I want the one that solves the problem and I want it
Yep.
soon.
Yep.
So, and I'm frankly willing to pay more for it than the average customer because I value getting the one I care more than, I mean, time is more
Hmm.
precious than many other commodities. So the faster the AI infrastructure that we have can help customers find products and buy them and get on with their lives,
Hmm.
the, the happier I am as a consumer and the happier I am as a Harper employee because then the e-commerce retailers are making more money and
Hmm.
paying us for the platform. So like
Yep.
it's win-win-win. How
Hmm.
you get to say win-win-win, by the way,
Yep.
not just win-win.
Yeah. Ooh, I like that. I like that a lot. I like that a lot. And I'm really curious to know, again, you may have not been able to like benchmark this or whatnot, but like, compute, like cost per, I guess like compute for cost. Oh my gosh.
cost per
The
inference
cost per compute, the cost per compute.
is like it's
Yeah.
negligible. Like you're going to be running these instances on a capacity basis, right? Like requests per second
Yeah.
slash memory slash storage footprint. That's the way kind of the compute bucket is
I see.
sized, right?
Hmm.
And then the memory size is fixed.
I see.
You're loading the model, so there's
Hmm.
input and there's output, and that's going to go back to your main infrastructure. So that's fine.
Hmm.
Uh, and then the speed, it's at the edge, so the speed is super fast. There's no worry.
Yeah.
So then it comes down to requests per second,
Hmm.
which frankly, as the application developer, you can throttle or not. Like,
Hmm.
do you make the inference for this customer or not? Like, you can
Hmm.
profile a bunch of stuff at the edge and
Yep.
decide when it's going to be valuable and when it's not. But imagine it, even if it doubled your request per second,
Yeah.
uh, if that doubled your cost, but it amplified your revenue by a factor of 10,
Hmm. I mean,
it'll pay for itself.
yeah. I was gonna say I was like, I can't math that, but I was like, I can't math that, but I do know that
And
it it,
math's
it
in the right
easily pays
direction.
for itself. Yeah. It easily pays for itself.
Yeah.
So yeah, yeah, that is phenomenal. That is phenomenal. And I mean, again, we see this applicable within e-commerce, right? But like, what are some other areas or other industries that you may think may heavily benefit from this?
I mean, inferencing at the edge is beneficial to everyone. I can imagine,
Yeah.
and I know we have customers who are doing things like, well, here's a use case I talked about with a friend of mine
Yeah.
who's in Formula E. That is
Hmm.
electric Formula One racing.
I was gonna ask, is it Formula One racing? Okay, it is. Okay, gotcha. All right, I'm not.
Not Formula One because it's all
Hmm.
electric cars, which, by
Yep.
the way, electric cars have ridiculous acceleration over internal combustion engines. So
Hmm.
Formula E is actually like crazy
Crazy, crazy.
cooler for someone
Hmm.
like me. But
Yeah.
uh, but here's a use case that I talked about with this friend of mine. 10 years ago, Formula One and Formula E building out race cars and testing cars at the track made
Hmm.
the decision that the bandwidth in communicating from the car to the pit was so small that they could only do one-way communication from the car to the pit.
Yeah.
They basically just streamed telemetry back to the pit.
Hmm.
Well, they're revisiting that now. 10 years later, they're like, well, we could do two-way communication. So what if
Bring.
what if we actually could push models to the car
Mm.
and based on the telemetry in the car, inference in the car, and
Hmm.
make recommendations to the driving for the next lap to the
Wow.
driver, which
Now
they
that
they
is
can
interesting.
yes or no,
Yeah.
get the confirmation. Same way, did they buy the recommendation or not?
Hmm.
Did they implement the recommendation or not? And then
Hmm.
literally every lap. So imagine the stuff we're talking about data centers, we're building
Yeah.
models, retraining. Imagine this
Yep.
happening now at the speed of laps.
Yep.
So you're pulling telemetry, you're getting data from the car, and
Yep.
after 5 laps, you're retraining and redeploying a model of the car.
Yep. Man, that I can only imagine, actually. I can only imagine. That's
So
that
the
is.
the point being, to your question, this isn't just an e-commerce solution. This is
Mhm.
applicable anywhere you can imagine. Uh, this you can. Everyone and their brother got into watching birds during the pandemic.
Mhm.
Like we're all locked at home, so we all bought binoculars and we sat there.
I absolutely did. I absolutely did.
Some of us are geeky enough that we actually bought birdhouses with cameras in them. And
Ooh, I did not do that, and I totally should have. I watched live streams of that, but I did not myself. No. So.
ima- imagine that your birdhouse has a model running in it that
Mm.
can identify birds,
Mhm.
things,
Yep.
but but it doesn't always get it right because sometimes the light's bad, sometimes it's nighttime, sometimes the birds tail to the camera instead of nose to the camera.
Mhm.
Imagine you're like, hey, when I log into my app, I want to be able to tell it, no, that's not a grackle. That's an actual like spotted chickadee from wherever, right? So I want to correct the model because I know more than the model.
Mhm.
Same infrastructure.
Yep.
It's doing
Oh,
the inferencing in the camera at the edge in the
yep.
birdhouse.
Hmm.
Coming back, you're correcting it in real time or not
Hmm.
real time when you're sitting on your couch doom scrolling birds you're saying, but
Yep.
you're telling the model management system how to correct the model
Mm,
thing and then putting a new model out to the birdhouse.
that is
Same
phenomenal.
same infrastructure, same
That
system.
is that is absolutely amazing. That is amazing. And wow, I'm thoroughly impressed. And I have not, I have not got a chance to play with like the Edge AI example, but I plan on doing that definitely this week. So I'm very excited. And yeah, for anyone watching, the GitHub repository will be within the description. And yeah, this is phenomenal. Like, thank you so much, Ivan, for uh, digging in, like just diving into this and elaborating on this examples, and even just not only just the and all the just the multiple applicable use cases um, that are, I mean, that are just simply possible. So, like, thank you, Ivan.
No worries. I'm gonna ask your listeners, our community, like the
Hmm.
GitHub post shows you the bare minimum. It would be great for this to be a community project. If you see a feature, you see something you want to expand, like clone the repo, fork the repo, make pull requests. We can make this thing wildly awesome as a community. It will
Yep.
take a lot longer if Austin and I have to do it ourselves.
Just a little bit, just a smidge bit, you know. Yeah. Absolutely, yes. Oh yeah. So yes,
And join
again,
us on Discord. Come to
yep, yes,
Discord. Come hang out with
yep,
us.
yes. We're all pretty nice. I mean, I think I'm pretty nice. So
I mean,
yes,
you got Wi-Fi.
I mean, only on Mondays. Oh wait, today is Monday, so we'll see about Tuesday. No, but no. Thank you again, Ivan. I appreciate you, and I hope you have a phenomenal day. So
Oh,
thanks.
it's sunny out. I can't complain. So I am now going to get myself out of my chair and walk around and see some outside air for a few minutes.
Please do, please do, please do. I will be doing the same.
Hey,
All right.
notice what it says. Harper
Ooh.
rocked.
Oh, I see it. Yep, Harper rocks.
Now
Yes.
wait, try it.
Oh, oh, oh,
Fast
there
and
it.
Harper
Try it.
fabric
Fabric
Harper
dot
up
Harper
fast.
dot dot fast. I love it. Yep. Fabric dot Harper dot fast. Try it out, y'all. Try it out. All right. Thank you
All
so
right,
much, Ivan.
of
All
course.
right. Have an amazing day.
You too. Talk to you later.
Talk to you later. Bye.